In this video, I will go over like the third question for 30-day LeetCoding challenge. So the third question is called maximum subarray. So let's go ahead and read the question together. Given an integer array nums, find a contiguous subarray containing at least one number which have the largest sum and return its sums. So we have an input that containing both like negative and positive value, as you can see, and the idea is we would like to find the greatest or the largest sum of contiguous subarray. So in order to solve this problem, you need to understand what is a contiguous subarray. So contiguous subarray is basically like a subarray that are next to each other. So this could be the contiguous subarray. This the whole thing could be a contiguous subarray. This is a contiguous subarray. Just itself is a contiguous subarray. And the idea is we want to find a contiguous subarray that when they add up all together, it gives the highest value. Okay, follow up. If you have figured out ON solution, try coding another solution using divide and conquer approach, which is more subtle. There are multiple ways of solving this problem, as the question mentioned. But one way of solving this is brute force, where we have two for loop. Basically, those two for loop will generate all the combination of the subarray. So first it have a I pointer and J pointer. So I will start right here, and then J will keep expanding. So the first iteration we will get this array. Second we will get -2 and 1. Third this, and then one we go over the whole thing. We move our I to here, and then we start expanding our J. So group of 3, group of 4, stuff like that. So that would be n squared, because you have two for loop. Each loop go from 0 to n. But and then once you create all of those contiguous subarray, what you can do is you can add them up, and once you add them up, you want to store the maximum number, and then return that value. And also it is ON square if we make an assumption that the summation is constant. Actually it's ON cubed, because once we generate the yeah, it's ON squared. Yeah, I mean, we could code it to be ON cubed, generated, and inside the loop we'd have another for loop, but it's not necessary. We can while we generate it, we can calculate it immediately. So that's ON squared. And the other strategy is ON. It's only one traversal. So the other idea is basically we keep recording. Is it dynamic programming? It's kind of it's almost like dynamic programming. So the idea is so let me copy the input. So the input is this, and the idea is we want to have another array that keep tracks of what is the current maximum value at that point. So the current maximum value at this point is -2, and then we have 1 right here. So 1 here, 1 will want to know, should I just stay by myself or should I add -2? And the answer is it should stay by itself. So And the reason is if we include -2, this value right here would be -1, so we don't want that to happen. So it's just like 1 still 1 right here, and right here -3. So -3 as itself, like should I include just myself or I include the previous value as well? So -3 should include the previous value as well, because if it's only like included itself, it will have only -3. But if it include the previous value, we would get -2. For 4, if you'll ask the same question, should I just be on my own, or should I also like account like the previous value? In this case, like 4 should only account itself, like it shouldn't like include the previous number, because 4 is greater than 4 plus -2. For -1, same idea, it should include with 4, so it should be 3. Right here, 2 should increase previous value, which is 5, and here 1 should include previous value, which is 6. In this case, -5, yeah, we want to include the previous value, which gives 1, and then 4 right here, we want to include a previous value, which is 5. So this is like kind of like dynamic programming, because like we relies on like the value from the previous, but actually we don't really care about the value. We don't really care about the value like 2 steps before that. We only care the one next to it. So what we can do is like we can just have like 2 variable that store like the maximum subarray, and then another one that store like the previous summation. So let's do that. Let's code it. So like the idea is like first we need to check if current num s is greater than num si plus, let's say this is like the dynamic dp table. So that's like the idea, but we want let's do it that way. So let's create a table called dp. So dp is basically the same size as the array. So you can do should initialize everything to be -infinity, and the reason is because we do not want to include that value. And then we can like traverse through it for value, for I in range of length. So now we traverse through that list, and then like I think this one can be 0. We can like check the first one as like a special case. So if I is equal to 0, dp of I should be equal to num I, else you want to check this condition right here. So if current num I, so if that current value is greater than the current value plus the previous value, you want to update our dp to be just nums I, else you want to store our dynamic programming to be nums I plus dpi minus 1. And then we can just return the max of our dp. Alright, let's go through the code one more time. So we created like a dynamic programming table to store like the previous value, but we will going to improve on this later once we pass all the test cases. So the idea is we want to record a dp to see we should update dp or not. So like the first case, the dp, there's no previous value, so we just like store dp of 0 to be that value at 0, at index 0. And then for the later on value, you want to check that value and compare it with that value added with the previous dp. So if it's if that value is greater than the number plus like previous dp, we just like want to keep that value. And then otherwise we want to include the previous value with the current dp. So this should, and then we looking for like the maximum in our dynamic programming table. This should give us the answer, but it's not like the most optimized. Alright, so it's good now. So like we mentioned earlier, we only care about the previous values, so we don't need like the whole dynamic programming table. So what we can do is like we can previous is equal to 0, and then we can current max is equal to 0 as well. So right here, instead of like storing in dp, we store it in previous. So previous is basically num_i. So whenever we see a dp, we want to replace it with previous. So this would be previous. So this would be previous as well. And here we should return current max. And we also need to update our current max as well. So right here, what we can do is, if so after we update our previous, we want to check if previous is greater than current max. We want to update our current max. So when we do this this way, it allows us to reduce the space complexity. So we have like constant space right here. And the reason that we can do that, like I mentioned earlier, we only care about like the value before it, only one before it. We don't care about like the previous like n value before it. That's why I can just like record previous and current max here. It's just like update every time like previous. Just update it. We want to check if previous is greater than current max or not. So this should work as well. Let's see. There we go. That's it. Yeah, so this is like another way. Divide and conquer. I think I don't want to go over this approach. It probably take some time like to do it with divide and conquer, but I just want to add on like to this question. I think like during the interview, the twist to this might not be divide and conquer, but it might be divide and conquer. But the other twist that I could ask you is return that subarray. Like how would you return the subarray instead of like the sum? Like how would you return this instead of this? Like what what type of like algorithm, like what techniques that you need in order to get this information. So that might be like something that they will ask us. So that's like something that we need to keep in mind. But this is just like another extra step, like to have like some sort of flag to figure out like when do we start to counting and when do we stop. So that probably need another like two variable. However, I'm not going to solve that. I'll just like put it out there to see if you guys want to try. Like instead of returning the sum, we also need to return the actual subarray itself. Alright, thank you for watching. The next video will be about move 0, and I hope this video have a little bit better microphone, like because like the last video it was like really bad. I used my AirPod microphone to record. This one I use an external microphone, so hope it's better. Alright, thank you. Bye.